All right, so here's one of our first big balances for material balances. So this is going to be a balance on a batch mixing process. And there are going to be two videos associated with this. One is for the setup of the problem, and one is going to be for solving the problem. So this video is going to focus on the setup. You need to check out the second video in order to see the full solution. All right. So here's what we're going to do. We're going to work through the problem and we're going to highlight things and put things into a setup that's really going to help us. Okay. So we have two methanol water mixtures in different flasks. The first mixture contains 40% by weight methanol. The second contains 70% by weight methanol. If we have 20 grams of the first mixture combined with 150 grams of the second, what is the mass and the composition of the product? All right, so first things first, we are mixing things together. So our unit process in this particular instance is some kind of a mixing process. So that's number one. Here's the unit process. We're doing mixing and we're doing it in batches. The next step is to think about how many inputs and how many outputs we have. So I'm going to use orange for my inputs. Now we have two methanol mixtures with water in separate flasks. So we have one input here and one input here. This one comes from flask 1, so I'm going to call this number 1. And this one comes from flask 2, so I'm going to call this number 2. Now we really don't have any other inputs here, so let's just stop there. Let's think about outputs, and I'm going to use blue for outputs. We want to know what are the mass and the composition of the product. Remember, product is a synonym for an output. So we have one product that comes out, and I'm going to call that number 3. Remember, we want to label our streams with numbers. Okay, we don't know anything about what's in this product yet. All right, the next step is to think about what is actually in our inputs. We don't know what's in the output, so we're going to have to figure out what is the mass of the output. So that's going to be the mass of 3, right? Mass of the third stream. So that's one thing to think about. And then we need to think about what's going on in our inputs. So I'm going to use purple here to look at this first stream. Okay, so the first mixture contains 40% by weight methanol. Okay, so what does that mean? Well, that means methanol is 40%. This is related to a mass fraction, right? So let's say that A is going to be for methanol, which means that in this stream right here, methanol is 40%. So that means X sub A in stream 1, that's what that is equal to 40% of the total mixture. Okay? Now, in each mixture, we have methanol and water. Okay, so that means there's something else in this stream. It can't just be 40% methanol and then 60% ether, right? Nothing, right? There has to be something else. So what I'm going to do is I'm going to say let B be water. And if there are only two substances here in this flask, methanol and water, if it's 40% methanol, then by default, it must be 60% water. So that means X sub B1 is equal to 0.60. Okay, so that's what's in number 1. Now I'm going to use green for number 2. The second flask contains 70% by weight methanol. Okay, well that means that X sub A in stream 2 is 0.70. which then means by default that the water in stream 2, so X sub B in stream 2, has to be 30% because that's the remainder. Okay? So that's the idea here with these setups. Now let's also take a look at this next sentence. We also have 200 grams of the first mixture. Here we go. That is going to tell us that M1 going into the system equals 200 grams. By the same logic, if we combine M1 with 150 grams of the second, that means M2 must be 150 grams. So you can see how our flow diagram starts to get pretty complicated. Because we are not creating or destroying mass, and we're just mixing, right? No reactions are happening in this mixer. That means that what comes out must be some part methanol and some part water. We don't know what these are. This is our set of unknowns. We don't know what this is. This is the mass part right here. The composition part is this right here. Okay? So this diagram that you see right now with this color coding technique, this is a fully set up, properly drawn flow diagram for this problem. Because there is no mixing, because there is only mixing, you might want to write a note to yourself that says no reactions are happening. That's an assumption we're going to make. Okay? This is a properly labeled flow diagram for this problem. I recommend using this highlighting technique at the very start if this is helpful for you to try and help you set up these problems. Okay? The last thing that we're going to do in this video is we are going to set up the general balance equation. That is the next step in what you do on any problem. You start with a flow diagram, and then you use the general balance equation. Okay, so we know that the general balance equation says the input minus the output plus the generation minus the consumption must equal the accumulation. Now we said we know that no reactions are occurring. I'm going to let you assume that in this problem. If no reactions are occurring, what terms must go to zero? Well, generation has to be equal to 0, and consumption must be equal to 0. You'll see me do 0 with a line through it so you don't confuse it with O's in this class, right? So we can cancel generation, cancel consumption. We also know, because it's a batch system, accumulation in a batch system is equal to 0, which means we can cancel this term. So if we are writing the general balance equation on this process, we can say that the input minus the output must be equal to 0, which means that whatever goes in must come out in this system. Input equals output. All right? That's going to get us started for this problem. Okay, so 2 steps to start every single problem. Set up your flow diagram. If this highlighting technique works for you, I want you to try it. And then write the general balance equation. In the next video, we will go through how to solve this problem.